Tuition Mobile, quality e-learning experience on the go.
You're welcome back to the class. We'll be talking about trigonometry 2. Okay, and here we'll be considering trigonometric ratios or special angles. Trigonometric ratios of special angles. Okay, and the angles we'll be looking at are angles of 30, 45 degrees and angles of 60 degrees. Alright, so after that we'll as well apply trigonometric ratios or special angles to simple problems. We'll do some applications of trig ratios, of special angles, to simple problems. Alright, so these are the two things we'll be looking at. There are a few angles that have relatively neat trigonometric ratios. Okay, that is why you see us calling them special angles. Special angles, they have relatively neat trigonometric values. Okay, what we mean by relatively neat here is that their values involve at worst a square root symbol, or can I say one square root sign. Okay, you'll understand better. And the angles we want to discuss here, we've mentioned them, angles of 30, 45 and 60. Okay, so we shall begin with the values in 45. Let's kick up these lessons with finding the ratios of values in 35. Shall begin with finding the values in 45 degrees. Okay, hence we shall use the triangle below. Okay, all right, if this were to be our triangle, and then assuming this triangle is inclined at the angle of 90 degrees. Okay, good, and you're told that this point is 45 degrees. All right, I can denote this triangle as some triangle A, B and C. Right, and so you know that the sum of the opposite sides make up the hypotenuse, and from your Pythagoras theorem, and so that is why you have that one, assuming the opposite and the hypotenuse, the opposite and the adjacent sides are 1 and 1. Okay, it means that the ratio of the sums of their roots, okay, the ratio of the sums of their square roots of their squares are equal to the hypotenuse according to your Pythagoras theorem. And so assuming these sides are 1 and 1, okay, and so how do we find the hypotenuse side? From a Pythagoras theorem, the hypotenuse side AB squared is equal to AC squared plus BC squared. Okay, so the side AB squared is equal to AC. AC is 1 squared, BC is 1 squared, and so AB squared is equal to 1 plus 1. AB squared is equal to 2, so that AB will be equal to the square root of 2. Okay, so we can write AB to be root 2, and so now we have all the sides of the triangle. We can try to develop a relationship for them in terms of the sine, cos and tan. Okay, so hence in terms of sine of 45 degrees, which is defined as opposite over hypotenuse, you can write as looking at the triangle, we have opposite there as AC over AB. Okay, and then AC on the triangle there is equal to 1 and AB is root 2. And so therefore sine of 45 degrees, okay, is equal to 1 over root 2. So if you punch this on your calculator, it will still give you the same thing, although it will give you the fraction being divided out. It will give you the fraction being divided out. Okay, it will give you 0.7071, and if you carry out this computation, you have the same thing as this. All right, so cos of 45 degrees, which is adjacent over hypotenuse, all right, which is equal to BC, I guess, yes, over AB, which is the hypotenuse side, and BC there is 1 over AB is still root 2, which gives you that cos of 45 degrees is equal to 1 over root 2. Okay, all right, so which means that cos of 45 is the same thing as sine of 45, because when you punch that on your calculator, you have the same thing, but in the perfect form, the root form, you have 1 over root 2, and tan of 45 degrees is equal to opposite over adjacent, which is given as the opposite side is AC and then the adjacent side is BC. Okay, and both of them are 1 over 1, okay, which is equal to 1. So that means tan of 45 degrees is equal to 1. All right, and so it continues like this, and you can see that from this particular triangle we have found that cos 45 is equal to 1 over root 2, and then sine 45 is equal to 1 over root 2, and then tan of 45 degrees is equal to 1. Okay, if you punch your calculator, you still have the same thing. We shall go ahead to determine other ratios for angles of 60s and 30. Okay, for values of 60s, for values of 60 degrees and 30 degrees, we shall find them gently. Okay, hence we shall illustrate using a triangle. Okay, we shall illustrate using a triangle that is an equilateral triangle. Okay, because it is only on an equilateral triangle that we can have all the angles being equal. Okay, that is each side, the angles on each side will be equal to 60 degrees each. Okay, and I hope we've not forgotten that the sum of angles in a triangle is equal to 180 degrees. If this is my equilateral triangle, okay, and just 60 degrees, this is 60 degrees too, and this is 60 degrees too. All right, and as I normally do, I give to each side 1 1 1. Okay, because you know all the sides in an equilateral triangle are equal, so I denote as 1 for all the sides. All right, assuming I have interest in finding for 60 and 30 degrees, that means I will have to dissect my triangle to divide into 2, and once the division takes place here, each side of the division becomes 30 degrees and 30 degrees. And so I have an assignment now to find the side of the triangle that I've divided. Okay, I have 30 degrees and then I have 60 degrees. Okay, and I have here to be 1 and here to be 1, so I wouldn't know what this is. ABC. Alright, so I simply have this triangle and a missing side now. 60 degrees, 30 degrees. I have a missing side. Alright, but if I should invert this triangle downwards, if I should invert it downwards, then I have the side 30 lying down, okay, so that the side of 30 can sit. The side of 30 can sit on the floor, and then this side 30 coming down, and then you have 30 degrees, and then the side of 60 can sit upwards 60 degrees, and then the sides changes to the side of 30A, and then the side of 60B sitting up, and then this other side C, okay. And then I know that BA is the side I'm looking for, and BC is 1, and then CA is 1 too. Alright, we shall go ahead to find the meeting side, okay. Finding the missing side, we shall apply the Pythagoras theorem. Okay. Okay, by Pythagoras theorem we have that the side AB squared is equal to BC squared, okay, plus AC squared, because Pythagoras theorem states that the hypotenuse side, the square of the hypotenuse side, is equal to the sum of squares of the opposite and the adjacent side. And so have AB squared is equal to BC squared plus AC squared. Alright, and then AB squared is 1 squared, BC squared is the side we are looking for, and then AC squared is sorry, let's go back. Right, okay, I think there's a mix up here. Once we dissect the triangle, so these sides become half and half, sorry. Okay, so that means AC, if I should denote as ABCD, it means that I have that BC is 1/2. Sorry, I think that's what I was supposed to look out for. Sorry about that. So I have 1 squared equal to BC squared 1/2 squared, okay, plus AC squared. It's simply not too logical. When you have 1 on a side and then 1 being divided into 2 becomes 1/2, okay. And so this gives us 1 squared minus 1/2 squared equal to AC squared, okay. Good, 1 squared is 1, 1/2 squared is 1/4, okay, which is equal to AC. Good, AC squared rather. And so carrying out LCM here, you have 4 minus 1 is equal to AC squared, okay, so that you have 3/4 is equal to AC squared. Therefore AC will now be equal to square root of 3/4, okay, which is as good as saying root 3/4, which is as good as saying root 3/4 is equal to 2. Therefore the side AC is equal to root 3/2. So we can go back and replace this side as root 3/2, okay, and then this side as root 3/2. Alright, and so we continue, and then to the next slide we can now develop ratios for this. All right, we can now quickly adopt that. Okay, all we'll do will be visiting back the slide to make sure we are in order. All right, so hence ratios of 60 degrees. Okay, and for sine theta, where theta is equal to 60 degree. Okay, all right, sine 60 degrees, which is opposite of a hypotenuse. Okay, which is equal to the opposite side there is AC and the hypotenuse side is AB. Okay, AC over AB. All right, the opposite side will be equal to the opposite side is equal to root 3, yep, over 2 all over AB, which is equal to 1, which is give you root 3 over 2. Okay, so therefore you can say that sine 60 degrees is equal to root 3 over 2. And if you punch with your calculator, you still have the same value of sine 60. All right, you still have the same value of sine 60 to be equal to 0.8660. Okay, so we'll go ahead for cos 60 degrees, which is equal to adjacent of a hypotenuse, will be equal to the adjacent side is given as BC, right? The adjacent side is given as BC over the opposite side. Okay, we'll come back to the right. All right, before we continue, we have to make some corrections on the mix-up we had during our computation. I think looking at the sides of the triangle from this point, the side that was dissected at was the side AC, and so it should be root 3 over 2 from our computation, and not AB. AB is 1, and then AC is root 3 over 2. Okay, so we effect the corrections here. What we are saying is that we have two triangles out of the dissection, and the part here is root 3 over 2, 1, and this side is 1 over 2. Fine. And this side too is for 30 degrees, because 30 degrees is here, and then 60 degrees at this point. And this side too is, assuming this is A, B, and C. All right, this is the AB part. Okay, good. And then it's sitting on CB. All right, so the part we're looking for is 3 over 2, and then the part CB is that, sorry, the part AC is 1 over 2. Okay, and then the part CB is root 3 over 2. Okay, and then we are considering angles on 30 degrees. All right, fine. I think this gives a perfect explanation of what we want to do. And so adjacent over hypotenuse, the adjacent side is 1 over 2, and then the hypotenuse side is 1, so we can say cos 60 degrees is equal to 1 over 2. Okay, and when you punch with your calculator, you find out that cos 60 degrees is the same thing as 0.5. all right, and so can be written in fraction as 1 over 2, and then tan 60 degrees. Okay, tan 60 degrees is equal to opposite over adjacent, which is as good as saying the opposite side there is BC, and then the adjacent side there is AC, which is equal to BC is root 3 over 2, and AC is 1, so then 60 degrees is equal to root 3 over 2. undefined. And then for finding that of 30, we will use the triangle we have there. For finding that of 30, we will use the triangle we have there, and the triangle there is given. So we have the following triangles. We have the triangle in the form of this, okay, where you have angle 30 degrees, and then you have 1 on this side, √3/2 on this side, and then you have 1/2. Okay, that's from the last diagram there, right? A, B, C, A, B, and C. Okay, so we can also develop ratios for 30. You can develop ratios for 30 using the triangle above. So ratios for 30 degrees, okay, we have the following. We have that sine theta or sine 30 degrees is equal to opposite over hypotenuse, okay, which is equal to opposite side is 1/2 and the hypotenuse side is 1, which gives 1/2. Okay, and then we have that therefore sine 30 degrees is equal to 1/2, and then we have cos 30 degrees to be equal to adjacent over hypotenuse, which is equal to √3/2, and then the hypotenuse side is 1, which is equal to √3/2. So therefore cos 30 degrees is equal to √3/2, and then tan 30 degrees is opposite over adjacent, okay, which is equal to 1/2 over √3/2. Okay, all right. So when you do the necessary computation, you have 1/2 times 2/3, okay, which will give you 2/2√3. Okay, this can take care of this, and then it gives you 1/3. All right. So therefore we can say that tan 30 degrees is equal to 1/3. So if you punch these ratios and punch them through their sign, these sign that you will as well get ratios, values of numbers having the same or significant or similar values as this. All right, there are other whole ratios, but we don't have proof for them. Okay, there are other neat ratios, but without proof, and it's good you note these ones too, although you rarely see them in your mathematics. And they are sine 0 degree, which is equal to 0, and then cos 0 degree is equal to 1, tan 0 degrees, which is equal to 0, and like manner we have sine 90 degrees, which is equal to 1, and cos 90 degrees, which is equal to 0, and then tan of 90 degrees, which is undefined. Okay, if you punch on your calculator, you will obtain it to be undefined, right? So we'll try to go over to the next part of going to the next level of the next part of our topic. Okay, we're going to applications of trigonometric ratios of special angles. Okay, all right. Okay, so we shall use the knowledge of special angles, okay, to resolve simple problems. All right, so the first example I want us to consider here is example 1, Example 1 is given as find the missing sides. Find the missing sides. The missing sides of the following. Alright, the following triangles. Okay, the following triangle. Okay, and you're given this triangle, and inclined at 60 degrees. You have 5 on the hypotenuse, and then B, C, A, B, C, D. Sorry, A, B, C, and then this side is C, the side A is missing, but the side B is equal to 5. And so you're trying to find the side A and C. Alright, let's look at the solution. Solution to this problem. Solution 1. Solution 1. Finding C. Finding the side C relative to AC. Relative to the side AC or the side A. Okay. Right. Sorry. Relative to side B. It's not A. AC is equal to B. Alright, and so how do we go about this? We should note that AC is which is B, is a hypotenuse side, and then that C is an opposite side. Okay, combining the two of them, we have opposite and hypotenuse, and relating them to our SOHCAHTOA. Okay, the only point that works out is the SO, because that's the only place you have opposite and hypotenuse. So we can say therefore sine 60 degrees is equal to C over B, which is equal to C over 5. Okay. Alright, so therefore sine 60 degrees is equal to C over 5, and then you have that 5 sine 60 degrees is equal to C. Alright, but from special angles, sine 60 degrees is defined as root 3 over 2. Alright, so you can say 5 times root 3 over 2 is equal to C. Fine. And so we can say that therefore C is equal to 5 over 2 root 3. Okay, so when you are told to, when you're given special angles, it's better sometimes you leave your answers in the form of special angles, so that you don't make mistakes. Okay, so because if you go into decimals, you might not see a decimal option as the answer to your computation, so always leave in fractions. Alright, so we go over into finding the side BC. Finding the side BC. Okay, and the BC side is as well the A side. Okay, and relative to the given side, AC. Okay. Alright, so we have the following. We have that AC is a hypotenuse side, and then we have that BC, which is also A, okay, is an adjacent side. Okay, so we have A and edge. Okay, and the only relationship that works out there is the car. Okay, we can pick the car out of this, and so we can find that by saying therefore cos of 60 degrees is equal to VC, which is also A over AC. Alright, okay, and so we can write this as big C over 5. Okay, and then we have that cos of 60 degrees is equal to BC over 5. Okay, and then you have that 5 cos 60 degrees is equal to BC. Alright, but cos of 60 degrees is equal to 1 over 2, so you can say that 5 1 over 2 is equal to B, so therefore B is equal to 5 over 2. Alright, so these are the methods for determining working out with special angles. There are other methods for determining other trigonometric ratios, but they are not for this class. They will not be talking about them here. Maybe when you get to higher classes you will talk about them too. Okay, but some other methods you can use to find trigonometric ratios, okay, by the use of your table of trigonometric. Okay, the use of trigonometric tables. Alright, these two can help you find trigonometric ratios. Thanks for being part of the class. Have a great day. Bye.